Hello students, today we'll discuss IB Physics SL paper 1 May 2017 time zone 2. No calculator for this paper. My name is Nariman Muallim. I'm located in Baku and here you can see my mobile and email. To prepare for exams you need either huge textbook from Oxford or short textbook from Tim Kirk Oxford 2014. And also from examiners you need IB Physics Guide, which has syllabus and cites booklet formulas, and Physics Data booklet with formulas. This booklet also will be available for you at the exam. Cover page of the paper, 45 minutes, 30 questions, 30 marks. A clean copy of Physics Data booklet is required for this paper. Question 1. A stone falls from rest to the bottom of water well of depth d. The time is given with uncertainty. Depth is 20 meters. Formula is for d. Uncertainty in A is negligible. What is the absolute uncertainty in D? Section 1.2. If we have multiplication, then we should use formula for fractional uncertainty. Fractional uncertainty on D will be equal to fractional uncertainty of A and 2 times fractional uncertainty of T. So A we neglect, then we substitute the values, we get 0.2. But to get absolute uncertainty, we need to rearrange this formula for absolute uncertainty. So D multiplied by absolute uncertainty give us 4 meters. Answer D. What is the vector quantity? Pressure is not, electric current not, temperature. Magnetic field strength should be. But we have here mistake. But we choose D. Question 3. A ball is tossed vertically upwards with a speed 5 meters per second. After how many seconds will the ball return to initial position? So we choose positive direction down, then initial velocity will be -5, g will be +10, and because it returned to the same position, displacement is 0. So how much time it took? From section 2.1, because we have no v in given and to find, we choose this formula, we substitute the values, then we take t out of brackets, and this is equal to 0, either time equals 0, which is the initial moment, or this expression equals 0. So this expression equals 0, we rearrange it, and we find time equals 1 second. A projectile is fired horizontally from the top of a cliff. The projectile hits the ground 4 seconds later at a distance of 2 kilometers from the base of the cliff. What is the height of the cliff? So projectile participate in two motions, horizontal and vertical. So we are interested in vertical motion because it gives us the limit of time, and vertically it moves from rest at acceleration g. So we use formula S equals so much, and we use information that so it was 4 seconds, 80 meters was the height, so we found the height. Extra information is 2 kilometers from the base of, so not used here. Question 5. A tennis ball is released from rest at a height h above the ground. At each bounce, 50% of its kinetic energy is lost to its surrounding. What is the height reached by the ball after the second bounce? So after first bounce, kinetic energy decreased 2 times, it equals to mgh, becomes mgh over 2, so it rises only to the h over 2. Then it falls down. Before strike it is mgh over 2, decrease 4 times, mgh over 4, it can reach only the height of quarter of h, so it is b. The initial energy of a block moving on a horizontal floor is so much. A constant frictional force acts on the block, bringing it to rest over a distance of 2 meters. What is the frictional force on the block? So section 2.3, work equals Fs cosine theta. Here theta is 0, so work equals Fs. We rearrange this formula for F equal work equal over distance. Not in the booklet we have relations that work done equals energy change, so we substitute into this formula energy change, 48 by 2 for 24. So question A, answer A, choice A. Efficiency of electric motor is 20%. When lifting a body, 40 joules of energy are wasted. What is the useful work done by the motor? So wasted means it was not useful. So a formula from section 2.3, efficiency formula, useful by total. And here total is useful plus wasted. So let's call useful x. Then we have the following. Efficiency 0.2 equals x over x plus 500. X plus 500 in brackets move to the left, multiply, and then x appears to be 125. Question 8. A net force acts on a body. Which characteristic of the body will definitely change? Here you should remember that tricky key is circular motion. Under force of at 90 degrees of velocity, speed doesn't change, and kinetic energy doesn't change. Direction of motion not necessarily change. For example, if object accelerate under the force or decelerate, direction of motion doesn't change. So the only thing that for sure definitely change is momentum, and here actually we have a formula for momentum. It is rate of change of formula of force, it is rate of change of momentum. So momentum is changing if you have force. Okay. A ball of mass 0.2 strikes a force sensor and sticks to it. Just before impact, the ball is traveling horizontally at speed. The graph shows the variation with time, the force recorded by the sensor. So first of all, from force time graph, area under the graph will be change of momentum. So left side, area under the graph, so change of momentum equals area under the graph. So it is triangle half height, which is F maximum, by base, which is 40. On the other hand, change of momentum is mv minus mu. From the information from to rest, so in the end it is 0. And it was so much, so the change of momentum is like this. So left and right part are equal, and we find F maximum. The graph shows a variation with time temperature samples x and y, same mass, initially in solid phase. Thermal energy is being provided to x and y at the same constant rate. What is the correct comparison of the specific latent heat and specific heat capacity? So from section 3.1, Q equals mc delta T for heating. If we put here energy provided equals power by interval of time, and then rearrange for gradient of temperature over time, we get power over mc. So inversely gradient will be inversely proportional to c. So more c, less gradient. So less gradient is with y, so Sy will be greater than Sx. Then formula for heating. Here you can do it on hand. The greater the specific heat capacity, the shorter the time. The longer the time. So this is, or again we can use trick, interval of time for heating, rearrange, time is directly proportional, more latent heat, more time is needed. So we choose answer D. A mass of ice at temperature -5 is changed to water at temperature 50. Which expression gives energy needed for this change to occur? So section 3.1 processes heating from -5 to 0 Sm delta T 5, then melting Lm, then heating from water 0 to 50 C water M50. Adding up all this we get answer C. A sealed container contains a mixture of oxygen and nitrogen. This is one ratio, and we should find ratio of average kinetic energy of one molecule to another molecules. We have average kinetic energy depends only on temperature. So because oxygen and nitrogen are in the same container, they have the same temperature and the same average kinetic energy, so the same ratio is 1. Question choice A. In simple harmonic oscillation, which two quantities always have opposite direction? By definition of simple harmonic motion, A equals minus kx, so A and x are always opposite. A girl in a stationary boat observes 10 waves crest past the boat every minute. What is the period of water waves? Period of time of one cycle, so we divide total time by number of cycles, and we did 1/10 of minute. A. The graph shows the variation with distance of displacement of particle of a medium in which longitudinal wave is traveling from left to right. Displacement to the right of the equilibrium position are positive. Which point is at the center of compression? I copied this diagram here, and what we see, all parts that are from 0 to 1 are moved to 1, 1. From 1 to 2 are moved to 1. So molecules are trying to come here. They already came here. Here we have compression. From point 3 they go away, and so B is compression. A beam of unpolarized light is incident on the first of two polarizers. The transmission axes of the polarizers are initially parallel. The first polarizer is now rotated about the direction of the incident beam by an angle smaller than 90, which gives a change, if any, in the intensity of polarization of the light. So section 4.3, intensity changes according to this rule if theta is angle between two polarizers. Because angle change, intensity will change. Polarization transmitted light depends only on the second polarizer, so we choose answer A. Intensity different but no change in polarization. A frequency of the first harmonic standing wave in a pipe that is open at both ends is 200 Hz. What is the frequency of the first harmonic in a pipe of the same length that is open at one end and closed at another? They give us information about this situation where we have antinode, two open ends. In this case, the total length of the pipe equals antinode, lambda over 2, so lambda equals 2L. For the case of the same length pipe with one open end, we have node, antinode, which is lambda over 4 equals length, so lambda equals 4L. So actually, wavelength increased 2 times, And if we look to wave equation or relation between frequency and wavelength, because wavelength increase 2 times, frequency will be 2 times less. So frequency of this one, we divide 200 by 2 to get 100. Answer C. The diagram shows two equal and opposite charges that are fixed in place, at which point is the net electric field directed to the right. So what we know that a force decreases with distance, and if we put positive charge here, it will be attracted to the right, to minus q, with greater force because it is closer, than repelled to the right. So net force will be to the right. Here we have both forces are acting to the left. Here greater force repulsion, but smaller force attraction to minus q because it is further. So we have to the right in x and z. So answer C. Question 19. A wire has variable cross-sectional area. The cross-sectional area of y is double that at x. At x, the current in the y is I, and the electron drift speed is v. What is the current and the electron drift speed at y? First of all, we have two sections, section A and section y. They're connected in parallel, so current is the same. Formula section 5.1 of booklet give us formula for the current. If current in x and y is the same, we write expressions, and we write expression for Vy. Vy will be 2 times less. So Ax, Ay is cross-sectional is double, so 2, so V over 2. So we choose the answer B, is the same current, but drift velocity 2 times less. A circuit contains this electric cell, 9 volt, internal resistance 1 ohm, together with resistor of resistance 4 ohms. The ammeter is ideal. XY is connecting wire. What is reading of the ammeter? So connecting wire is connected in parallel to 4 ohms. So actually the total resistance of this part is negligible, because for parallel connection it is less than the smallest. So this is called short circuit. So this resistor doesn't do anything. So we come here, so we have short circuit in which have EMF and one resistor. So formula total external resistance equals 0, current is 9 ampere, 9 volt over 1 ohm. A positive charged particle moves parallel to a wire that carries a current upwards. What is the direction of magnetic force on the particle? So this is the current. If particle is positive and move upward, it is the same as we have current, conventional upward. The wire creates magnetic field that is anti-clockwise. So it is at this point into the paper. The current is upwards. According to Fleming's left-hand rule, the push will be towards the wire, so to the left. Answer choice A. Two satellites of mass m and 2m orbit a planet at the same orbit radius. If F is the force exerted on the satellite of mass m by the planet, and A is simply the acceleration of the satellite, what is the force acceleration of satellite with mass 2m? So section 2.4 give us the force of attraction of the satellite with mass m. For mass m, we have the following expression. Acceleration will be force over mass, so acceleration will be given by this. Actually it is g. Here I just use a. For 2m masses, the attraction will be 2 times greater because mass will be 2 times greater, so 2f. If we put 2m into this formula, nothing changes. So it is the same, it doesn't depend on m. So acceleration will be the same. So we choose 2F and A. The gravitational field strength at the surface of the Earth is G. Another planet has double the radius of Earth and same density as Earth. What's the gravitational field strength at the surface of the planet? So section 6.2, G equals this, but mass equals density times volume, times volume. So volume of sphere is 4/3 r cubed. So we put this information into the expression for G density, and we get that G depends directly proportional on R. So if R increases 2 times, G also increases 2 times and becomes 2G. Question 24. Atomic spectra are caused when a certain particle makes transition between energy levels. What is this particle? In the nucleus, in the atom, only electrons can move. They change position, and we choose answer A. A half-life of radioactive element is 5 days. A freshly prepared sample contains 128 grams of this element. After how many days will there be 16 grams of element left behind in the sample? Every half-life decrease of active elements is 2 times. So after 1 half-life we'll get 64 grams, after 2 half-lives 32, after 3 16. So it will take 3 half-lives, but each half-life is 5 days. So we multiply 3 half-lives by half days, we get 15 days. Answer C. The binding energy per nucleon of beryllium is 6 MeV. What is the energy required to separate nucleons of this nucleus? So we have 11 nucleons. Each requires 6 MJ, so total will be binding per nucleon by number 6 by 11, 16. 6. The reaction does not occur because it violates the conservation law of. So electric charge +1 +1 conserved. Baryon number 1 2 2 1 no. Not conserved. So it is B. So actually we can stop here, but if we look at C, we don't know whether pi is left on or not, and we know that strangeness 0 here and 0 here. Okay, no problem. The main role of moderating nuclear fusion reactor is to slow down neutrons. Just memorize. A. 29. A room is at constant temperature 300 Kelvin. A hot plate in the room is at temperature 400 Kelvin and loses energy by radiation at rate of P. What is the rate of loss of energy from hot plate when temperature is 500? So loss of energy in energy released by energy absorbed from the room. So formula for, from section 8.2, formula for power radiated is given by this. So 400, for 400 we have energy released minus energy absorbed, room. For 500, energy released by minus energy released. The ratio, we find ratio and then we simplify, we get D. In physics, question 30. In physics, a paradigm shift denotes the introduction of radically new ideas in order to explain a phenomena which introduces paradigm shift. So I think that atomic spectra brought to quantum physics, so we choose answer D. Paper is over. Thank you for your attention.